How's it going, everyone? Welcome back to another CP104 review session. Today's review session is going to be focusing on files and 2D lists, so let's jump right into the content. Starting off with files. Files in Python are pretty easy to use, they aren't very convoluted, and you only have to remember a few key things when working with them. So first and foremost, before we get started, notice I have a file.txt right here, which is just a simple plain text file with two lines, I love CP104 and hello world. And we're going to be accessing this file for demonstration purposes. So to open this file, let's just declare a file variable and use the open keyword. So this file variable is going to be the variable that we run all of our methods on. Everything that we need to do with the file, we run through this variable right here. So then the open function requires us to pass a name of our file as a string. So let's do that. It's going to be called file.txt. And then as you can see here, the IDE prompts us to also include a mode. So in Python, there are three main modes that we can open a file in. R, which stands for read, W, which stands for write, and A, that stands for append. So there's more than this. However, these three key modes are the only ones that we really encounter in CP104, and they're the only ones that we really need to work effectively with files. So let's start off by calling the file and opening it as a read mode. So to access the content within the file, let's create a line variable and say file.readLine. So this will read the first line in the file and add that value into the line variable. So let's print out this line and let's see what we get. So as we can see here, we get hello world, but we also can see that we have a line break here, which is kind of odd. However, if we look back here, we can see what Python is doing and why it's giving us this end line here. So when we read the line, it's going to be reading this line as a whole. When we highlight this line, it doesn't really look like there's anything past this hello world. However, since there is another line in this file, there has to be a break line character, which is /n. So when Python reads this, it's also interpreting that line as having an end line character. And so that's why we have this end line here. To get rid of that and to only use the data within the file and not any end lines, we can use a string method that we covered in the last review session, which is .strip. So what this will do is remove any white space that isn't directly in between, like any words. Any trailing white spaces or any beginning white spaces is what this strip will get rid of. So let's run this now, and we can see here, it's just a plain hello world string. All right, so to get the rest of the lines, let's print out the rest of the lines. We can say while line does not equal empty. This means once we get to the end, that read line function will return an empty string. We want to print out line.readLine. Line.strip. So we actually don't even need to print this line because we're going to be printing the line, and then we're going to be saying line is equal to file.readLine. Oops. And there we go. And we can see here, we get hello world and I love CP104. Another good practice that we should use when using files in Python is making sure that we close the file as well. So we can just say that. We won't really run into any issues if we don't do this. However, it's just better for efficiency's sake. So if you have a really large program where you're opening a bunch of files, you'll definitely want to do this or it'll slow it down by quite a significant amount. All right, so that's pretty much all we need to know about the read. It's pretty simple, and this is really the only thing that we have to be concerned about is reading the lines from the file itself. And we can do that with a simple while loop. It's going to be the same every time. And so now let's move on to the write mode. So let's delete all this and let's set our mode to W. So this will write to our file. And let's give it some text to write. So how we do that is we say file write, and then we say, let's say, Stephen is the best. All right. So, and let's close this file up. And let's run this. Let's see what we get. So we don't get anything returned. However, when we go check this file, we can see that Stephen is the best is the only thing in this file. So you might ask why that happened and why we didn't write to the end of the file. So what W does is pretty much it clears any file that exists at file.txt, and then it writes whatever we give it. So W is also good because it'll create a new file if there doesn't exist one at that path. So let's just call it file2, and let's run that. And if we see here on the file explorer here, we can see that we have another file, file2, that contains the same thing. So whenever you want to create a new file and write to it, always use this W. If you want to clear something within the file and then write to it, also use this W. But if you want to add on to a file, we have to use the A mode. So let's take this now and just return to our other file. Let's delete this file too. We're not going to need it anymore. And file text, and we can run this and check our file. And as we can see here, we've appended Stephen is the best. Again, as we can see here, there's no line break. And if we want to add that, we're going to have to come into our string here and put the /n like I showed. So now if we run this one more time, we can check our file and we can see that a line break was inserted and then Stephen is the best was appended to our file. So essentially, that's all you need to know about files in Python. They're very useful if you want to store information outside of the script itself. They can be very useful in pulling in data, which you can use for any sort of project. And yeah, they're pretty easy to learn. You just have to make sure that the mode that you're using it in is proper, because let's see an example of that. Let's say I have an R and we try to do an write operation onto it. We run that and we can see IO unsupported operation, not writable. And that's directly a cause of us opening it in the R mode instead of the W or the A mode. So here's our first example. We have to implement a function called customer by name, and we want to find the record in FH that matches the name that we're given. So our file is going to be this customers.txt file, and it's pretty much a bunch of customer records. So it's a customer ID, a customer first name, customer last name, the transaction amount, and then the day the transaction happened. So let's start off with defining a default result. So if we find nothing, what's our result going to be? Obviously, we want it to be an empty string. So let's just set that up. And then let's read the first line from the file. Oh, sorry. Line is equal to fh.readLine.strip. So we want to read the line, and then we want to remove any trailing white spaces. So now, since we've gotten the first line, we have to start our iteration so we can check the rest of the file as well. So we can say while line does not equal the empty string. We have to also split each line into specific fields. So one field, that's the ID, one field, that's the first name, one field, that's the last name, and so on. So let's do that. We can say fields is equal to line.split. And we want to split it based on the comma, because the comma delimits every single field that we have. So now we have a list of each individual field for the records. And as we can see here, the fields that we care about are fields at the index 1, because this is a second thing, and index 2, because it's the third thing. And so if we're looking for a record that has Tom Black, we want to see Tom Black as our name, right? So we want to take field 1, add a space in between it and field 2, and then check if that is equal to the name. So let's do that. Fields at 1 plus a space plus fields at 2. If that is equal to name, then our result is just going to equal line. And we're just going to look for the first thing that we find in this file, the first record that matches, and we can just say break after that. This is just going to terminate this loop so we don't waste any more computation looking through if we've already found a result that contains the name. And then again, to continue this loop, let's go to the next line is fh.readline.strip, and then we can just return the result. All right, so that's pretty much our function done. Let's run it really quickly so we can see if it works. Let's print out, or actually, so this file, this fh is going to be an open file. We have to keep that in mind. So let's say fh is equal to open. Our file name is customers.txt, but I have it in an example files directory. So let's right click on it and we can copy a relative path. So this will pretty much give us a path corresponding to where this file is. So we can do that, and we want to open it in read mode. So then we can say print customer by name, and then we have to give it a file handler. So we give it fh and then a name. So let's choose one of these names here. Let's say Avali. There we go. And let's run this. And we get Avali's record. So that's well and dandy. So now let's change it to a name that doesn't exist. Let's say Avalel. And we just get nothing because we're returning an empty string. So that was the first example. Let's move on to the next one. So for this example, we have a method called filter by year. And we want to find all the customer transactions that happened in a given year. And we want to return multiple results. So we have a list of records that match that year. And it's going to be a list of strings. And again, we're going to be using the same customers.txt file. So let's get started. The start is very simple and similar to before. So the only thing that's really different is that we have to initialize an empty list instead of an empty string because we want to be adding records onto this list. And for every record that we find in a given year, we want to add to this. So line is again equal to fh.readline.strip, and then while line does not equal an empty string, then we can say fields again is equal to line.split by a comma. And so now we can pull out the date, and that is going to be the last thing in the line. So either we can say -1 or we can say 4. Let's just say -1 because it's the last thing. So that's going to pull out the date. It's going to pull out a string of the date. So now we want to split it again to only focus on the year. So we can say current year is equal to date.split. And this time, instead of splitting with a comma, our delimiter is a dash. So we're going to have to split by a dash. And we can see that our year is always going to be the first thing in our date. So then we can say 0, and that's going to be the first thing in that split current year, split date list, and it's going to give us the current year. So then we can check if current year is equal to year. Then we want to say results.append the line that we just saw. That's going to be the current record. And then we can say line.fh.readline.strip. However, there's going to be, and let's return that, there's going to be an issue with this code, and the issue is going to come right here. Do we see how year is of type int? Our current year, even though it's a number in this text file, it's always going to be text because it's a text file. It's always going to be a string. So this current year is currently a string, and there's no cases where the current year is going to equal the year because the year is a number and the current year is a string. So we have to convert this to an int. So this int operator is going to convert anything that is able to convert to an int into 1. So now this is going to be, for example, the number 2005 instead of the string 2005. So now let's say 2005. So we should expect to see 2 entries made in 2005, and it should be Jane White and William Lee. So let's run this. And there we go, Jane White and William Lee. And let's see what happens if we choose one that isn't in the file. There's clearly no 2010s here. So let's run that, and we get an empty list as expected. So let's move on to the next example. Our next example is going to be diagonal sum. It calculates the sum of the diagonal elements of a square matrix. So imagine we're given a 2D list that is of size 2 by 2 or 3 by 3. The sides just have to be even, and we want to calculate the diagonal. So it seems like it would be a little bit hard to do, but the solution is actually pretty elegant and it surprises a lot of people. So let's start off by defining our base sum, which obviously if we have no diagonals is going to be 0. And then let's iterate through our length of matrix or our rows. And because we know that this is going to be equal size of like 3 by 3 or 2 by 2 or whatever, this range is also going to be iterating through the indexes of the columns. So we can say that sum is equal to sum plus matrix at I. So this is going to get the current row that we're at. But also we're going to say I again, and this is going to return that incremented column. I'll show why this works in a second, and then we can just return sum. And that's actually all there is to it. So let's take a look. Let's create a 2D list. Let's go 1, 2, 3, 4, 5, 6, and 7, 8, 9. Okay. And let's just format this so it looks a little bit better. Okay, cool. So we know that our iterator is going to start at 0 because, well, that's what the range starts off at if we don't give it a starting value. So we start off at 0 and we're indexing into the value matrix 0, 0. So we know that that's 1. So our sum, let's just actually run this here. So sum starts off at 0 and I is equal to none when we start off. Then we update I to be 0. And then we get matrix at I is matrix at 0 and 0, which is equal to 1. So this is our first thing here. And then we add this matrix 0, 0 to sum. So our new sum is 1. And then we iterate through again. So our I is 1. We index at 1, 1. And at 1, 1, we can see it goes diagonally. It skips 1 row down and 1 column over to 5. So this is going to be 5 now. And our sum gets updated to 6. Now, last iteration, it's going to be 2. This is going to be 2, 2. And matrix at 2, 2, we can see is 9. And then our sum is going to be 15. So that's a pretty simple solution to a seemingly complex problem. And it's just because we're understanding how we use 2D lists. So we're moving over 1 column and 1 row every time. And that forms the diagonal line that we're looking for. So let's run this and just verify our answers. So let's print diagonal sum of this matrix here. And let's delete these. And we can see we get 15. So let's move on to our last example. Okay, for this last example, we have a method called replace element. And we want to replace all of the occurrences of the value old with the value new in a 2D list. So pretty much what we're doing is searching for a certain value and then replacing that value with our new value. And we don't return anything, we just change the list that we're given. So first and foremost, let's iterate through the rows. For I in range length of matrix. So this is going to get the numbering of the rows. So 0, 1, 2, 3, 4, up until rows minus 1, or length of matrix minus 1. And then let's say for j in range, length of matrix at that certain row. So at matrix I, we're going to go through each column within this matrix at I. So at the current indexed matrix row, we're going to go through each element. So this is going to give us every single element within this 2D list. And now we have to check if j is going to be the element itself, I is just going to be the index, or sorry, j is also going to be an index, my bad. J is going to be the index of the column, and I is going to be the index of the row. So we're going to have to index into the matrix and check if it's equal to old. And if it is, then we set it to new. So we know how to do that. We say matrix at I, so matrix at row I, and then at column j. So this is going to give us the value at row I and column j. If that is equal to old, then we update it. And we say matrix at I at j is equal to new. So there we have it. That's the entire thing. And yeah, let's test it out. So we don't get anything, but let's define a matrix as 1, 1, 1, 2, 1, 1, 1, 2, 3, 4. Okay. So now let's say replace elements of matrix, and let's replace all of the ones with negative ones. And we know that it's not going to return anything, so we have to print out the matrix itself after. So we're going to expect to get -1, -1, 2, -1, -1, -1, 2, 3, 4. So let's run that, and there we go. We get that answer. And let's try to replace something that's not in the list just as a sanity check. And we just get the same matrix back. So I hope you enjoyed this review session. As always, if you need any of the code snippets, they'll be below in the GitHub link. And yeah, thanks for spending some time with me today.